In this lesson, we're going to write what's called a Hadoop streaming job to process some of the text from that post small file that we created in the last lesson. Hadoop streaming is actually useful for creating jobs in really any language that can read from standard in and output to standard out to process text from Hadoop files. So we're actually going to create ours in Ruby. The first thing we're going to want to do is install Ruby. All right. So install Ruby 1.9.3. Okay. And while that's installing, we'll switch over to this other window that I have open on the server so we can actually start writing our first MapReduce job. Now, a MapReduce job consists of two phases, the map phase and the reducing phase. And in the map phase, the set of input files that you feed it, which can either be multiple files from a directory or all the files from a directory or really just a single file, it takes that and it splits them out into multiple chunks that get sent to the mapper. The mapper works with those and then outputs things, usually key value pairs, which then get shuffled together and sorted and then sent to the reducer. This will all make a little bit more sense as we actually start digging into the code. So let's just get started with writing a map job. Now this is going to need to be executable. So we say this is going to be a Ruby program. And we're going to read from standard in. Like I said, in a Hadoop streaming job, each line from a file, an input file, gets fed to a mapper as a line that can be read from standard in. Now, first off, we have to figure out what we actually want to do. So we said we wanted to look at the posts file. I think a good thing to start with would be to say look at the tags for posts. Say we want to actually parse out the tags from the various posts. So you can see there's some tags. So that's tagged Perl there. Here's something for Python, for data, and for CSV. All right, so we can see the basic format there, so we can think about how to actually structure this. But let's say I only want to pull out tags. I actually think there are only tags for question posts. So first off, let's start off and determine whether or not something is a question. Now, if you look at the README, it will give you a clue as to how to do that. Here, we see it's in the post type ID. If it's a 1, it's a question. If it's a 2, it's an answer. So we can just say if post type ID equals 1 appears in this line, we know that it's an actual question. We'll say, just for good measure, we'll say only 2 questions so people know what we're doing here. Now, this is XML, the post file, but we're not going to use an XML parser. Hadoop streaming does have an XML input format, but for now it's going to be easier for us if we just work with just raw text. So we're going to pull it out using regular expressions. So I'm going to take some code that I previously written and just copy it in and take you through what that does. All right. So basically we want to say, look for the tags, match against the tags here. If there's a match, grab it, remove the bogus XML formatting on the side, and put in tags and clean it up. Then loop through each of the tags, and this is the actual part where the mapper does. So this is the part here where it's parsing, where the mapper is doing its work. This part right here is where the mapper is actually outputting data that gets shuffled and sent to reducers. what we're outputting is the actual tag, and then a tab character, and then a number of times it appears. Now, for this, we know each post can only be tagged with a single tag once, so we're just outputting 1 as like the count of the tags. The idea for this MapReduce job is that it's going to go through and count how many times each tag appears in all of the posts combined, so in the entire corpus. This should pretty much finish the mapper part of the task. Now, we can actually test this without going over to Hadoop. There are command line utilities that allow you to easily test Hadoop streaming jobs. Let's do that really quick to see if this mapper works the way we want it to. First, we're going to have to make this executable. Now, if we just want to test it with a really small subset of data, we can just tail like the last 10 lines of the post small over to the mapper. So here we're just piping it out to the mapper. And it'll just the mapper will just read it from standard in. Okay, so from those 10 lines, we see that we have these various tags. We have fonts, .NET, Linux, iPhone, iOS, and memory, and each of those appears once. And actually, 1 is going to be, in this column, the mappers are always, for this task, are always going to output 1. Okay, so now we're ready to actually write the reducer. Now, the phase that happens in between the mapper, when the mapper sends out data into standard out, and when the reducer receives it in standard in, is called the shuffle phase. And what the shuffle phase does is Hadoop actually takes all that output and it sorts it by this key right here. So if you have 2 mappers running and each output fonts like 20 times, it'll sort it so that all the font counts will be next to each other, so they all go to the same reducer. So let's write a reducer real quick and we can see how that looks. All right, once again, it's going to be a Ruby program. And we're just going to go through standard in, line by line. Okay, we're going to read line by line. Now, each line we're going to expect to have a tag and then a 1 associated with it. So what we want to do is we want to count how many times we see each tag and then output that from the reducer. So we're going to have to know what current tag we're on and what the current count is for the tag that we're looking at. And that's going to have to be outside the iterator for the lines on standard in. That's because if you have, say, font appear 3 times and then .NET appear twice, you're going to see font in 3 consecutive lines, and then you're going to all of a sudden see .NET, and that's the point at which you're going to want to output that value and then move on to keep account for the new tag that you're seeing. So basically, we're going to pull the tag and the count out of the line. Remember, we had separated it with a tab character. We want to convert the count to an integer. Now, so that we can add them up. Now, here's the part where we say, okay, is this the same tag as the one we're keeping track of, or is it a new one? So if the tag is equal to the current tag, we know it's the same one. So we want to say the current count and increment that by 1. Otherwise, we want to see, 1, make sure we're on a current tag. Because there are some lines in the file that actually are not, that they're actually on the first tag, on the first line that gets read in, current tag won't be set. So here's where we output the previous value that we're counting on. That's the current tag. We separate it again by a tab. And the current count. All right. And then since it's a new tag, we want to set the current count to 1. And here's where we set current tag to the tag. So if it's a new tag or even if it's the same tag, we're keeping track of that. All right, so that completes the reducer. So what we expect to see happen is the reducer will output a tag name and a count. And they'll be in no specific order, but each tag should only appear in the output once. Let's test this out. Now, the command line for testing this is a little bit more complex than the previous one. So just like before, we want to grab some of the lines from post small and pipe them to the mapper. And then we want to pipe the output of the mapper to the sort command, which is a command line utility that will take all of that output and sort it. Like I said, normally in Hadoop, a Hadoop job, it does this for you. So you output from the mapper, and then you receive from the reducer, and it's already sorted for you. Here we just use the sort command, and it fakes like it's Hadoop. And then we want to put out to the reducer. Now, this actually isn't going to run because I haven't modified the reducer to be executable. So let's do that really quick. All right, and test. All right, so we have a little error. Let's go in and fix that real quick. All right, it looks like our error is on this line here. All right, now let's try run it again. Okay, so we see, oh, things get output, but for some reason fonts shows a count of 0. So we'll want to fix that. All right, so we know it's not in our mapper because it's actually outputting the proper values. So the error must be in our reducer somewhere. Ah, yes, it's because font is the first value that gets set. So one way to fix this will be to make this value nil. And then optionally set current count here. All right, let's run it again to see. All right, so everything's 1. Now let's see if we can run it on a larger set and actually get some tags that have, some posts that have similar tags. Yep, and sure enough, we can see that things seem to be counting correctly. We have multi-threading appearing 3 times, Objective-C appearing 9 times, JavaScript's really popular. Okay, so that looks like it's pretty good. Now that we're done writing the mapper and the reducer and done testing them out on the command line, we're ready to actually send it up to Hadoop and see it process there. So to send jobs to Hadoop, you use the Hadoop executable. Remember, I mentioned in the intro to lesson 1 that with batch processing in Hadoop, the core concept is that you're shipping the code to the server. So instead of moving data around, you're moving code to server so it can process it locally. This Hadoop command line actually sends the code to the server and then kicks off a job that'll run this MapReduce job. We want to find where in this case, we're using a special jar called Hadoop Streaming, which is what you use to run streaming jobs. So there's that jar. And then we want to say the input is going to be input/posts small. And then you have to specify an output directory, which is where the output of, the actual output of what the reducer puts out shows up, and also information like how the job ran and stuff like that. So we're going to output that to, we'll just call it lesson 1 output. And now we have to specify the mapper that we're going to use, which is the mapper that we just wrote. and the reducer. And finally, we'll need to copy these files up to the cluster. So by default, the map job will only get the input files that were specified here on input. So when we say file mapper RB, it tells this Hadoop executable to copy that file up so that it can actually be used in the process. And you can use that to copy other files, like if you have a dictionary that you're working with, or if there are other necessary files that your mapper or your reducer will need access to when they're running on the cluster. So finally, let's copy the reducer, and that should kick off our job. So basically, you get a lot of output here about it, kicking things off, sending it, and here is where it actually says, okay, it's starting up the job. And it gives you percentages of how far into the map phase you are and how far into the reduce phase you are. The other thing that's interesting here is it gives you a tracking URL. And we're not going to go to localhost, but you can see there's somewhere you can go so you can get information about how this job is doing. Let's jump over to the browser and take a look. So we actually had this open before, which was the job tracker that we used to make sure that everything was running. So here, we see there's this actual job, and it's actually already completed. If we click in there, we can get details about the job. So map phase, 100% complete. There were 2 tasks, both of which completed, and they never failed. So 2 tasks means the input was split into 2 separate mappers. Remember, we read from only 1 file, but it was split out to 2 separate processes. When it reduced, all the reduction was sent down to 1 process. So that's the distributed nature. You don't always have to have the same number of maps and the same number of reduces. That's also a setting that can be optimized. As you can see here, you get in the cluster summary information, you see the map task capacity and the reduce task capacity. And you can configure those on a per node basis. Now we're only running 1 node in a pseudo distributed mode, so 2 and 2 seems fine. You could actually have more because a large EC2 instance has more computing power than that, but this is good for our purposes. So that's it for this lesson. In this particular part of it, you've learned how to write a Hadoop streaming job to process text files. We'll do a lot more of that in the lessons to come, so you can fine-tune those skills and get practice with it. Thank you.